Good morning, everybody. My name is Andrea Keefe, the Meetings and Events Coordinator with IPC. Before we kick things off today, I just wanted to point out the upcoming E-Textiles event or events. We have one in September in Philadelphia, and the other one will be in Germany in November. One thing to note is the Philadelphia event in September, we only have a few seats left. So if you are interested, please feel free to click to go to the URL, and I will also be sharing these in the post-event wrap-up email should any of you be interested. I'm excited to kick off today's webinar on We're Successful When You're Successful, Manufacturing E-Textiles. If you have any questions during today's webinar, please send them using the chat or Q&A feature on your control panel. At the end of today's webinar, we will go through the questions and answers at that time. We will also be providing everyone with the speaker's contact information along with a recording of today's webinar in approximately 1 to 2 business days. Today, I am pleased to welcome MaryAlice and Oona from Nypro, a Jabil company, to be our featured speakers. I'll now turn it over to the both of you.
Let me get this on to share real quick. Can you see the presentation?
Yes, I can.
Awesome. Perfect. Okay, so hello everyone. Thank you for joining our presentation. We're successful when you're successful. We're discussing E-Textiles and E-Textiles manufacturing. My name is Oona Oksjärvi, and I have MaryAlice Gill here with me. We both work for Jabil. Jabil is a global product solution service provider, and we help our customers with design, supply chain, and manufacturing. And we do products from packaging, which could be different containers for different products, to medical, where we do pharmaceutical delivery systems and medical devices, and of course electronics, where Jabil does board designs and board assembly for automotive, aerospace, and consumer products, for example. And MaryAlice and I, we work under division Nypro Consumer Health, which focuses on consumer products around wellness and then to medical products as well. And the team we two work with is focused on textile products and integrating electronics and textiles. My background is more on the textiles and clothing industry, but I've been working with E-Textiles for about 5 years. My role is a product development engineer, where I'm responsible for testing and material selection and reliability and quality of the products and the process as well. And then I have a background, MaryAlice here, with material science engineering, where we studied mostly semiconductor fabs, so electronic materials, but also a broad range of materials. I've been with Jabil originally as an engineer, where we were working, I was working in the capabilities team to develop printed electronics as a manufacturing capability. We were looking at different material characterizations and applications for the printed electronics so we can align with the kind of future growth of electronics and our customer needs. Okay, next, let's take a look at what we're going to talk about today. First, we're going to go through some key challenges and process limitations in E-Textiles manufacturing. Then we're going to go through some key points for successful collaboration. And then how to identify technical requirements for E-Textiles products. And then last, we're going to show you a development process for mass production. So to highlight some of the key challenges that we've seen in some of our E-Textiles work, that the E-Textiles, because it's so new, there is just a really vast lack of standards. There's a lot of work going on between IPC and other organizations to kind of build the foundations for these, but it does hinder some development because there isn't a fallback of documents and requirements that have been done for the E-Textiles products. Another big challenge is that the electronics components and materials and the textiles materials are manufactured with really wide tolerance. They are on
magnitude of scale difference in terms of the precision that they go through. Part of this is due because the capabilities for textiles is pretty limited. It hasn't had to have the kind of work for functionality as electronics has done to make the precision that it has. And, you know, it doesn't have the drive of Moore's law for electronics needs. And then the machinery that can build, you know, say the fibers into fabrics or even the fiber formation is just not consistent. So if you have those tolerance stacked up from, you know, the raw chemistry to the device, that can kind of hinder some of the work. A lot of times the requirements are fairly ambiguous. You know, if a customer comes to us to build a product, it needs to be comfortable or readable. We need to kind of take those high-level requirements and break them down into things that are actually testable work. And another key part of that is oftentimes the companies are going into spaces that haven't been done before, so the requirements aren't really well understood what the product needs to have in order to be successful. You know, so enabling technologies is lacking as well. The materials are being asked to do so many more things than before, and so a lot of collaboration between different industries of material suppliers and then manufacturers as well as universities to kind of make better materials that can have all the functionality what E-textile needs to have. And then because these E-textiles are being asked to do so many different things, oftentimes those requirements have very conflicting properties, and that requires our team and other teams like us to kind of either develop a structure or a stack that can kind of limit some of those conflicting properties and enhance what you're looking for functionality. And also there are some times that there's it needs to kind of be a compromise. So to highlight some of the very different properties of the industry, you know, that need to kind of be evolved as these two merge. I mentioned it earlier with the tolerances, nanometers, angstroms, mils for electronics, and much greater scale for textiles. So there's a lot of different processes from, you know, raw material chemistry to actual assemblies for both of these industries. Different testing organizations drive both of these industries as well as what you're looking for function. Those testing is is very different. Different materials that are used, and then a key highlight I wanted to look at was the supply chain. Even though the process flow for supply chain might still be very similar for both, you know, material spec for a textile isn't going to have the properties needed for an electronic right at this current stage. And so when we're doing material selection for our bombs, we have to do a lot of characterization that you don't necessarily need to do for either of these industries separately to make sure that we're speccing materials properly and we're getting the right things to meet our product needs. For instance, if we're picking a material that has a film and may have particular chemical plasticizers inside, that as we're developing our structures or we potentially want to print electronics on it or adhere some electronic element to it, our process may be limited because that plasticizer can become soluble and affect the finishing. Another example would be, outerwear textiles have a coating on them so that it can get those types of properties that it needs for waterproof, and that will also impact how we can process to create a final device. So, these enhancements of textiles will really help to move forward the e-textiles industry. Also, another key point for both of these is that there is a really vast difference between how we make e-textile products. You could have a textile that's like, an armband, say, where you put your cell phone in so that you can listen to music while you run. There's that level of e-textile integration where they're very two separate products being used together, to something where it's fully integrated, where you have component plates in textile fibers or laminated into textile, where the fibers or fabric is actually part of the electronics and the connectors.
All right, let's take a look at one example of bringing electronics and textiles together. So here we have a sports bra with integrated heart rate monitoring sensors. The sensors you can see on the third picture, they're placed on the inside of the garment against the skin. And then on the outside, on the first two pictures, we have these connectors. They're snap buttons that you attach the actual electronic device to, which will then transmit the signal to your smartphone or your sports watch. So the snap buttons used here are actually a component that have been used in textiles and clothing industry for a very long time. And they're a very common closure system for garments, for example. But here, they're actually used as electronically conductive connector, not a closure system, which means the same component now has all these new requirements and pretty much a new specification. And then what you need to figure out for the specification is like what kind of dimensions for the component are acceptable, what kind of variation in dimensions is acceptable, what kind of materials can be used so that it will transfer the signal with a high quality, how will it work with all the other materials and all the other electronically conductive materials in the structure, and all those things. Then in addition to just to the component itself, you have the assembly methods and the machinery used to attach the component to the garment. Again, those have been created for you to attach a snap button on a jacket or on a shirt, where you can achieve a reliable connection for that use, but then now you want to achieve a reliable electronical connection through it, and you will want that connection to withstand the use when you put on the garment, if you take the garment off, when you wash it, when you stretch it, and all that. So then you have to find out if the machinery is capable of achieving high enough quality for your application. And so even when you have an existing component that's just used in a new way, you have all those things considered.
So to highlight some of the quality issues that we've seen when you're pairing material of the rigid plastic housing or electronics with a conformable textile, the tolerance incompatibility kind of shows itself here. There's a lot of handwork in textiles processing that, electronics is obviously a very automated process. And you have kind of a bulky structure of a seam of a textile. If you look at your clothing, most of the seams or parts that are kind of stabilized are a little bit bulkier. So this can cause some, aesthetic issues and also potentially durability issues. If you see on the picture, there's the really smooth, fine, narrow corner of the plastic housing, where that can possibly cause a durability, function failure, overuse, depending on how you use it. The textile, in this case, I believe we were looking at like a plus or minus 10 millimeter quality in terms of dimensional change of the textile that we had to meet, which is pretty high quality in terms of, keeping high control for the parts, but then aligning that, A, with handwork, and also B, the dimensional change. Once you've got a plastic part that pretty much doesn't change at all, we have a lot of misalignment issues that we had to face, and this requires us to kind of really develop our specifications and rethink how we specify our parts, but also being innovative and kind of recreating our assembly flows so that we can improve our quality.
Let's talk about standards next a little bit more. MaryAlice already touched on the topic earlier. So basically, there's a lack of standards in the textiles industry. And here's some things that those standards would actually support in the industry and hopefully will in the future. So standards would create a consistency across industry. At the moment, we have electronics side and we have textile side, and both of them that have their own standards and the way things are standardized are slightly different. In the electronic side, you have so many standards, everything is pretty much standardized. On textile side, there is standards for how to test things, for safety of the product, and like chemical substances and things like that. But there is a difference on, for example, test standards. On the textile side, you have your standardized test method, how to test something, but the standards don't really tell you what is acceptable and what is not acceptable for product functionality. You usually have to decide what is the result you want yourself. And then again, about in testing, you can't necessarily take electronic test standard and just apply that to your E-Textiles product. The textile portion might not withstand the test, or the other way, to take a textiles testing standard and use that for your E-Textile product. That doesn't always work either. One example would be that a lot of the fixtures and the machines used in textile testing are made out of metal, and then when you're working with conductive materials, you might have some issues, and those metal fixtures could affect your results. The another thing that's missing is common language. Again, the two industries both have their own terminologies and own languages. And then in between in E-Textiles, there aren't really defined terms and definitions of things, and people might be talking about the same thing with two different words, or they're talking about two different things with the same same word. So the lack of common language makes the communication sometimes a little bit more challenging. Then again, about supply chain, we as a manufacturer, we work with our customers who bring the product to market, and we have to align with them about the product requirements and the product testing and all that. And then we also discuss with our supply chain, with our material suppliers, which could be textile suppliers or they could be electronic suppliers. And then when you bring all those things together into one product to achieve good quality, everyone across the supply chain should understand what the requirements are and what the use of each component and each material is. And then lastly, requirements and reliability. There aren't really standards that tell if your product meets these requirements and is tested in this way, then you can safely say that it's a functional E-Textiles product and it will be also safe to use. So everyone working in the E-Textiles area at the moment kind of have to come up with those requirements themselves and also come up with the needed reliability testing. And that means there's a lot of work that needs to go into that. So you might have to create your own test protocols and test plans and also test methods. Then you have to make sure your test methods give a reliable result so you can trust it. And then you have to also make sure that you're actually testing the right things. So oftentimes these make the project a lot longer because you need to do all those things well, and that takes time.
So as we talked about are some challenges that we face with E-Textiles development. There's quite a few things that we can do to bridge the gap. It's just part of it is time as we continue to make more products, more customers, and more manufacturers, more material suppliers get on board as an industry matures. We'll be able to work towards success. There's the expectation for expertise. We need not as much the depth of expertise, but being able to have vast knowledge areas across different fields is really important for the E-Textiles because we're looking at how to make textiles that have electronic functionality. Being able to collaborate with all the different companies across the supply chain, from those that are making chemistries to those the end users needs according to like the OEMs, because we need to be able to collaborate effectively to understand what we're actually creating and what the needs of those products are. And there's tons of collaborations with different industries and organizations and universities so that we can do a lot of the groundwork for the research. The project and product, there's needs to have flexibility. There are a lot of assumptions, I think, from that the textiles, because it's been around for so long, you know, we've worn clothing and used blankets for forever, that it's really simple, but there's a lot of knowledge and a lot of technical information and challenges in just making regular textiles, especially as we add a lot of these functionalities. So understanding that we can't assume that an e-textile, because the textile, is going to be a really quick turn cycle from product conception into being able to be mass produced. We need to be able to, again, align on some of what the product needs are and understand, you know, we're working with to understand the expectations of our customers and what we can create so that we can kind of help them to develop requirements and meet the needs of their users and their customers. And then I also believe that really doing a good risk analysis of our products, because we don't have the industry accepted standards for e-textiles. We need to do a lot of work in testing and selecting the right materials and designs so that we can create a really safe product. So with some of these pieces in our toolkit, I think we can have really successful e-textiles, and so we can bridge some gaps with some research.
All right, here we have a product development process towards mass production. So everything starts at ideation phase, where you create your concept and the use case. This part of the process is usually on the responsibility of the one who's bringing the product to market, which would most of the time be our customers. The reason for that is they're the one who know the market, and they know their end user who will be using the product and how, for how long, in what kind of environments the product is used, and so on. After defining the concept and the use case, you can move to the design phase, and the manufacturer should be involved at least at some point of the design phase, because here you're going to have to go through your design for manufacturing or design for assembly when you're creating your product specification. So the purpose of the design phase is to come up with your kind of product design package and your product specification. That would include the drawings with dimensions and acceptable tolerances. It would include your bill of materials, how the product will be packaged, any accessories, any logos, labels, or artworks on your product. And of course, then product requirements. The product requirements is usually the most challenging part of the design. So as a manufacturer, we need measurable and objective product requirements that we can test against. The use case and the user needs are the foundation for those product requirements, but you can't necessarily just take a user need and say, this is what the product needs to be, because if we can't measure it, we cannot make sure we need it, meet the requirements. So one example would be the comfort that MaryAlice already mentioned. So user need would be the product needs to be comfortable. Can't really objectively measure that. There's no test method for that. So what you need to do is break it down to smaller bits. And for example, you would come up with a list of requirements. Let's say if the product is lightweight, if it's breathable, if it's elastic, then it will be comfortable. And those things are a little bit easier to measure than comfort. So from design, you can move forward to the testing phase where you test your materials, as well as your structures where your different materials come together, and of course test the product. And in this phase, you also analyze and test the process to make sure the product is mass producible and the process is efficient. Oftentimes in the testing phase, something comes up that requires you to go back to the design, update your drawings or update your product requirements or update your materials or product dimensions. After the test phase, there's the build phase. So when you're fairly confident that it makes sense to build a larger amount of products, you move forward to the build. You can build units for different purposes. Fit for purpose would be to make sure your product does what it needs to do and what is expected from it. Fit for market would be building to see you can actually build a product that meets the specification. And then lastly, fit for production, you make sure you can actually ramp up and scale up your production. First two might still require some design changes, but the last one is pretty much just tweaking the process. So as said, I have those little arrows there. In E-Textiles, you can expect that you have multiple iteration cycles. Usually, you cannot know all of your product requirements and all the pass-fail limits for those requirements in the beginning. You're going to have to do testing and you have to build things. Some issues only come up when you're building 50 pieces or 100 pieces or 300 pieces. So that's why you have to be prepared to go back and update your design and then test and build again, and then you might find out something else, and then you have to go and update your design again. And then you repeat these cycles as many times as you need to, but at the end you should have a mature product and a product you're comfortable with that you can then deliver to your customer.
So just to kind of summarize the E-Textiles manufacturing work that we've done, we hope you guys enjoyed it and learned a little bit. I know we kind of stayed a little high level so that we could kind of capture a wide area of what E-Textiles work we do, touched on some of the challenges and how we can kind of overcome these challenges with standards and collaboration to kind of get to a very mature E-Textiles industry. E-Textiles, we touched mostly on the wearables aspect of it because that's the work that we do from the consumer and medical spaces. But E-Textiles is hoping to be everywhere. We have textiles all around us. We sit on E-Textiles, we walk on textiles. Our curtains are textiles. So there's a lot of work being done where E-Textiles will be, all around us. We would like to take any questions now that you guys may have.
Thank you both. We do have one question. What will be criteria for ESD, electrostatic discharge?
Requirements for ESD, like in terms of E-Textiles. So I'm hoping I'm interpreting this question right. I don't know if these are multiple questions, but what will be criteria for ESD, electrostatic discharge, handling methods, washing instructions? So right now, there are, the ESD shirts that we have that you'd want to work in manufacturing, those exist, and that's kind of, I think, a good baseline in terms of kind of developing criteria. But that is a challenge because textiles don't necessarily have the same ESG requirements, and they create the static discharge. So I think one piece of work is to kind of have static ionizers and stuff in terms of the handling, but that is a challenge, and I think it's going to see how as the products become more complex, those will start to kind of grow with some of the standards work. That is a big discussion with some of the teams that we've worked in.
Yeah, and to add to that, like on end products, it would really depend on the product and the product structure. I think at the moment there's a lot of focus on protecting the electronics from all kinds of outside factor, whether it's ESB or or moisture or things like that.
Yeah, and some of the fibers are kind of done so that it could possibly encapsulate and not necessarily allow some of the interfering.
Yeah, and then it's also dependent on where the product will be used, because like in sports applications, for example, in heart rate measuring, it might affect the signal, but the user might still get what they need out of the data. But then when you go to medical field and where you're making decisions and diagnosis based on the data, that's a totally different thing. So I don't think there's a simple answer to that at this point.
Yeah.
Okay, thank you. And then another question that just came through. Are there established standards for washability on a garment made from E-Textile?
No, I know that there's, really robust standards for typical textiles, and that's something that there's a lot of work being done. I believe IPC might have a preliminary standard that they've started, or maybe that came from APC, I can't remember. So there is work being done there. I know that Clothing Plus and now, Jabil has kind of done some work in terms of, because washing is a really, really rough process, and that can also, kind of show you other failure modes just in washing. So, if you wash it a few times and it doesn't work anymore, then you kind of investigate, is it a certain amount of cycles that caused failure, or can you do inspections to figure out if it was something wasn't encapsulated properly. But yeah, there's work going on right now, but there are not, as far as I know, standards.
Yeah, so basically for the washing text method itself, there are standards that in the textiles industry that can be used. But then what will be measured after the
output is an electronic
washing, that's not standardized.
Yeah. So one of the talks you'd actually had for some of the E-Textiles IPC documents was you need to know before testing, you'll do like a kind of like as received type early testing of like baseline and then characterization, and then you kind of do your conditioning, and then you do your test. Right now, that's kind of how most of the E-Textiles is done, but really what happens, the in situ of your conditioning is actually really important as well, and could probably lead to a lot of information. But because of the way the tests are done, we're leveraging from either textiles or electronics. It's really hard, and there's going to be a lot of work to kind of develop those tests so that we can test during conditioning.
Okay, great. It looks like those are all the questions so far. So with that being said, thank you both so much for taking the time today.
Awesome. I hope you guys enjoyed it. Thank you.
Thank you. Thanks, everyone. Have a good day.
All right. Bye.